Hello, today we're going to be solving equations using division, and we want to try to tie past learning to what's coming up next. So in our previous lessons we used the following property, and we actually used it to help us solve equations that contained addition and subtraction, and that property is called the identity property for addition. A property is just a rule that works for every number. So if we have any number, A, and we add 0 to it, it equals the number that we started with. So this property looks like this. If I have a number, 8 plus 0, I would get back 8. 3/5 plus 0, I'd get back 3/5. So x plus 0 would leave me with x. And that's what we've been doing when we solve. We've been using the inverse operation to basically make a 0 or zero this out. So I really have m plus 0, which leaves me m, which is the goal to isolate the variable, and then this side I have 21. So we've been using that property to solve. Today, we're going to use another identity property to help us solve equations that contain multiplication. And this is the identity property for multiplication. 1 times any number A equals that same number A. We prefer to write it side by side because that's the high school way to write it. So we're going to see it more frequently that way. So 1 times -9 would be -9. And 1 times 15 would be 15. 1 times 23 would be 23, and 1 times x would be the same thing as just x. That's what we're going to need to use. The next concept is something that you might be familiar with, you might know the answer to. We will also use this concept. Any number divided by itself equals, well, what would you say if I took 3 divided by 3? Or 9 divided by 9? Hopefully you'd tell me that this is a 1. And it is. So any number divided by itself is 1. Now this might seem like it might be a -1 because I have a negative divided by a negative. But if you recall, the Margar face for this would be a negative divided by a negative, which is a positive. So this is also 1. -25 divided by -25 is 1. And even if we had decimals, we'd still get 4 1/10 divided by 4 1/10 would be 1. So finally, it asks what operation, addition, subtraction, multiplication, and division, those are operations, is demonstrated in the following example. So if 4 is next to 5 and 2 is next to x and -8 is next to y, what operation is this? If you said that it was multiplication, you are correct. So, knowing that, now the question is, so what operation do you think we need to use in the equation below? If we see 3 and x next to each other, it means multiplication. So when we solve, we use the opposite. So we would build the wall. I want to undo multiplication, and I do that by dividing. And we're going to show our division as a fraction bar. I want the 3 to go away. This is 3 times x, so I'm going to divide by 3. And I have to do it on both sides, just like when we solved using addition and subtraction. And now here's what happens. 3 divided by 3 is 1. And we just talked about that 1 times x, or any number, would just be that number, x. So we've isolated the variable. The purpose of this is to isolate the variable. And on the other side, it's 7. So that's where we're going today. Please turn to the next page. So we're solving multiplication equations that contain multiplication using division. When we solve equations, our goal is to isolate the variable on one side of the equal sign. If you recall, we do this by doing the inverse or opposite operation of the one that is given. Recently, when we solved either addition or subtraction equations, we needed to zero out the constant that was being added or subtracted. Today, we'll work with multiplication equations, and we will need to solve using division, because that is the inverse or opposite operation of multiplication. However, instead of zeroing out, we will need to create a coefficient of 1. Coefficient is a number in front of a variable. So the coefficient of 1 will be in front of the variable, and 1 times anything is that anything. So these are all examples that you see here of the identity property. A plus 0 would give me A, y minus 0 would give me y, 1 times m would give me m, 1 times x would give me x, and 1n, the preferred way to write this, would be n. So that's what we're trying to get. We're trying to get a coefficient of 1 in front of every single one of these variables. So our new way of writing multiplication, by the way, is side by side. So let's start this. I'd start it by building a wall. Get my pen going. Side by side is multiply, so the opposite is divide. So I do that on both sides. So both sides have to look the same. This becomes 1. 8 divided by 8, any number divided by itself is 1, leaving the a. That's the reason we did that. We want the variable by itself, and the answer is 6. Based on this, I'd like you to pause the video and do 2 on your own. Using that same step-by-step guide, we would divide by 6 on both sides. This becomes 1. 6 divided by 6, leaving n, equals 9. Number 3, you can see, has just a little bit of a twist. We have a negative number. So we're going to have to bring in our Murphy-Dillon or our Margar faces to help us recall what to do. The good news is we start solving this exactly the same way. Side by side means multiply, so I'm going to do the opposite. I'm going to divide by 7, and I have to do that on the other side. So this side, 7 divided by 7 is 1, and 1 times x is x. Over here, however, we have a negative 21 divided by a positive 7, and so we're going to get a negative answer. So x equals negative 3. Now what I didn't do was the check, and check starts out using the original problem. The original problem said 7x equals negative 21. So let's see if that's true. We're going to keep the 7, that's from the original problem. We're going to replace x with our answer, which we think is negative 3. And if that's correct, we should get back negative 21. Would you please check that on your calculator? And it turns out that is correct. So now let's go on to the last set. This time you might notice that the coefficients are negative, and this is where a lot of students have difficulty. When we are working with addition and subtraction, if I have a plus 3, then I do the opposite. Plus 7, I do the opposite. I subtract 7. Or if I had a minus 7, I would do the opposite and add 7. But our opposite operation for number 4 is not adding or subtracting, it's dividing. So that's our opposite operation. We must use the same integer that's given. And that's because if I have a negative divided by negative, it's going to give me a positive. And I want a positive 1a. I don't want a negative 1a because that would leave me with negative a. So if I took negative 9 divided by positive 9, that would leave me with negative 1a or negative a, and we don't want that. So we have to use the same sign of whatever is given because our opposite thing that's happening is division. Instead of multiplying, we're dividing. So negative 9 divided by negative 9 is positive 1a, which is just a. And on this side we have a positive 18 divided by a negative 9, and that is a negative, and the answer is a negative 2. So this certainly might be one that you'd want to check. I would start out with negative 9a equals 18. All I did is copy down the original problem. I'm going to replace the a with my answer. So I'm going to take -9, and I'm going to replace the a with my -2. That's what we think it is. And if I'm correct, it should equal positive 18. So using our Margar face or the calculator, a times a negative would indeed be a positive, and it is 18. So that checks out. You do not have to do all the checks, but I always double check if I'm not confident in my answer. That's a great way to look at it. You could also do a mental check. So let's continue. Try these on your own. If you want to pause, you may, and then you can come back and check your answers. Alrighty. So would you please double check, and sorry about my messy face here, but I just want to let you know when I have a negative divided by negative, it is indeed a positive 4, and I didn't cross out the numbers next to the variable so you could see what I was doing. Thank you for listening, and have a good day.